So we're evaluating limits analytically, and we're going to be looking at this particular problem right here. And of course we're in whatever you want to call this, section 2. So as you can see here, we're doing we're going to be doing direct substitution. That's what I meant to say. Let's go ahead and hit the help button and see what's going on here. So we take a 3 and we plug it directly in. That's doing the direct substitution, and we're going to end up getting 1 minus, and this is 6, so we're going to get a negative 5 in the denominator. So what we're really concerned about is if we end up getting a 0 over 0. And of course the answer here, I'll go ahead and hit that, is negative 7. But if I were to plug, if x was approaching a number such that if we got 0 in the denominator and 0 in the numerator, we would end up having to do something else, and that's more than likely factoring. Now, of course, we can stop here, but I'm going to take this one step further, and that is assume that, for example, x was approaching a half. Right, and if we plugged a half in right here, we'd get 1 minus 1, which is 0. Let's go to the whiteboard and just pretend that x is approaching a half here. So we have the limit as x approaches, let's say, a half. And we had 2x quantity squared minus 1 over 1 minus, and I believe that was 2x, wasn't it? And of course, when we plug a half in, we get 0 over 0. So what we're going to want to do is factor this guy. So we're going to rewrite the limit. Remember, write the equal sign here. X approaches a half. And so let's say that well, we're going to go ahead and factor the numerator. So we have 2x minus 1 times 2x plus 1. Now, I know this is not the original problem, but we're just covering bases here. Alright, now what you could do here, you notice that we don't have a 1 minus 2x in the numerator. But what we could do is factor a negative 1 out of the denominator. So this is kind of a tricky thing. Just rewriting the limit. If I factor out a negative 1, I'm going to bring this factor to the middle here. Okay, so we have 2x minus 1 over, or let me continue to rewrite this here. And this becomes 2x minus 1 down here in the denominator. Because we pulled a negative 1 out. Let me do a little side work over here, actually. And so as you can see here, if I distribute the negative 1 across inside, we have a 1 minus a 2x. So we're pulling this negative 1 out, and then we rewrite this. But to properly rewrite this, you would write this as 2x minus 1, not negative 1 plus 2x. Alright, so hopefully you're with me on this now. So then you just take this negative 1. Now this is the property of the limit here. You can take these coefficients, if you can, and pull them out front. And so we end up with, running out of room here. And now I'm going to go ahead and cancel these guys that are the same out, and we're left with 2x plus 1, and I'm going to put some parentheses around that. And now we can take the half and plug it in, so we end up with 2 times a half plus 1. Now remember, this whole thing is in parentheses because we have this negative 1 out front, and so we end up with 2, so this ends up becoming a negative 2. So in our in the very beginning here, we could actually write this as negative 2. I need to write a little neater, I guess. But anyway, now this is the case depending on what x is approaching here, right? In the original problem, we didn't have to go through all of this, even though we could, and then plug our number in. We'd still get the same answer out, right? But there we go.